So basically, yeah, between your Friday spritz and you, there is my talk. I will try to do my best to not waste your time. I'm Michele. I moved to London a couple of years ago. I work at YPlan. We are hiring. Uh, I'm a member of Web Devs, Web de London, but most important, ReactJS Italia. You should join us on Facebook and on Slack, and follow me on Twitter. So when I get back to London, I can tell my son, "Hey, I got a lot of new followers in Italy." And I used to have a beer, but now I've done a rebranding recently. You might be interested in the book I'm writing. It's going to be ready in January 2017, React Design Patterns and Best Practices. I basically take everything that we say in our Slack channel of the ReactJS Italia community. I'm writing it in the book. Yeah, this is the thing. In the last 2 years, I worked a lot in the CSS in JS topic. I basically did everything I could do to write my CSS in JavaScript, and I've written blog posts, I created a repo and everything. And then I asked to the community, would you like me to talk about styles or error handling? And basically they decided error handling. I don't know if it was for challenging me or they're tired of me talking about CSS in JavaScript, so I'm gonna talk about errors. So this is an endless spinner. Have you ever experienced an endless spinner in your life? How many of you are? That's cool. There are some ways to fix it. One is refreshing a lot of times. Another way is it's clicking until it gets fixed. Or sometimes if you look to your console, you're gonna see something like that. And unfortunately, we experienced this at YPlan recently, a couple of months ago or maybe more. And it was a Thursday, 5:30. We have to go out for dinner in an Italian place and to celebrate some achievements of our team. And the customer support told us, oh, there are some customers that are experiencing an endless spinners. Unfortunately, it was 5:30. We had to leave at 6, and we didn't manage to fix it. We didn't manage to find the root cause of the problem. The day after, I woke up and I got a diff from Aaron. Thanks, Aaron, for fixing it. And obviously now it's fixed. But I found out that errors are very, very bad. Obviously, we all know that, but they make unhappy customers, and that's very bad also because the customers are paying us, but also I've seen that they make developers very, very unhappy because we couldn't enjoy our dinner that much before we got drunk. But in the beginning, we were pretty oh shit, we were thinking about the error. So I said, okay, now the error is fixed, but I don't want this to happen again, or no, I'm sure it's gonna happen again, but if it happens again, I want to fix it very, very quickly and be happy. So let's talk about errors then. So when I was working on the slide, I went to my favorite website to learn JavaScript, and it's W3 Schools. And they say a very cool, it's a very right thing. And normally, errors will happen every time you try to write someone new JavaScript code, and that's true. That's how it works. And then I also looked for some numbers just to get an idea. And basically, it turns out that we spend half of our time writing bugs and half of our time fixing bugs. So I'm not sure if it's worth it. And but first of all, we decided we have to define what's an error, what we consider an error, because if you want to solve a problem, first you have to understand the problem. And these are some definitions, incorrect results. So you are expecting A and you're getting B. That's an error. Unintended behavior. So you should see your dashboard, for example, but you see an endless spinner. Or if your application is in an inconsistent state, so I don't know, you logged in, but you cannot do some operations because the system tells you that you are not logged in. So these are some definitions. And also we found out, this is the most important part, that there are two types of errors. And there are some operational errors that, for example, if you do an HTTP call, the HTTP call may fail. But we don't consider this a real error, like, because it's something that could happen. I mean, you could expect that to happen. We were more concentrated about the unexpected ones, the ones that you think, oh, my code is perfect, it's not gonna fail, and it will fail. So the unexpected ones are the ones that we are gonna try to catch. And the first thing is that your code will fail. Yeah, you have to accept it. It's very, very hard, you know, because you've written like all the tests, you tried your code with all the different variations you could try. We don't have staging, but if you have staging, you tried it on staging, you have QA, whatever, it will fail, it will fail. You have to accept it. Once you accepted it, you figure out that the problem is not the error by itself, but the problem is that you are not handling the error. And the biggest one is that you are letting your users find the bug for you, because the worst thing that happened to us has been that our customers found the bug and they told us that, hey, there is a bug here. So that's actually very, very bad. They should not do that. They should be happy. They should use this is the product that they're paying for. So error handling, what's error handling about? So error handling is about like giving feedback to the users. So your code is gonna fail, that's okay, but you have to tell something to the user, because if they like stare at an endless spinners like for 10 minutes, you are also wasting their time other than their money. Also, error handling helps you finding errors quickly, because you don't want your users to tell you, hey, there is an error. You want maybe to monitor your application and discover your errors before your users. And sorry. And also, if you do error handling, you can store important information, meaningful information to solve the problem, because it's not enough knowing that, okay, there is a problem here. Sometimes problems are very, very hard to reproduce. For example, in our case, we couldn't reproduce it because it was happening only for some customers, only under some conditions, only on production. I mean, only on this, one single browser. So it's very, very hard. So if you can store important information, that's good. It's going to be easier to fix the bugs. So the requirements for following this talk are, other than obviously React, I'm going to talk I'm not going to talk about Redux, but I'm going to talk about some concept related to Redux. So is there anyone that don't know Redux at all? Oh, that's perfect. What about Redux Saga? Okay, perfect. So basically, Redux is this thing where your components fire actions. Actions basically describe how the state has to be changed. There are reducers listening to these actions, and they mutate the state according to the action, and then they notify the components. And then that's fine. It works. It's great. It's great. But sometimes you have. But this is synchronous. And sometimes you have to do asynchronous operations. So, for example, you have to call an HTTP, an API, or reading a file or whatever. It's asynchronous. So you can use Redux Saga for that. So basically, you set up some watchers that basically they are similar to Reducer in the sense that they listen to all the actions or the action that you tell them to listen to. And they can do something which is called effect. They can fire side effects. So, for example, an action can tell Redux Saga to do an HTTP call, for example. And when the HTTP call returns something, another action is fired, and it goes into the reducer. It updates the state and the components. So just this, nothing more than this. You may have, if you are using Redux and you don't know about the Redux Saga, I guess you're using Thunk. And it's like you use Sagas to do the same thing that you do with Thunk, but it's a little bit cooler. It uses generators, so it's more modern. You can be like more cool. You can add it to LinkedIn and all that kind of stuff. And also we're gonna talk a little bit about Webpack. You don't need Webpack at all if you use React, but in this case it's useful for a couple of things. So basically, everyone knows Webpack, right? Okay, no. So Webpack is basically a module bundle. So instead of writing all of your JavaScript in one single big file and copying all the dependencies inside of this file, you can split your code base into different modules and you can import those modules. And Webpack is going to create the big bundle for the browser for you. And it has some cool feature like code splitting. So you have a big bundle, but you can tell Webpack to load different parts of the bundle according to the user needs. There are loaders, so loaders are basically, my favorite one is the CSS loader, so you can import not only JavaScript file, but also CSS inside Webpack, and then it has a very cool plugin system. We're going to talk a little bit about the configuration, but it's not, if you don't know it, it doesn't matter. And yeah, so we're basically, in this talk, I'm going to go through, before like common error handling solution, like base ones, and then the most interesting part is that where I will show you what we have actually done. I've done a lot of experiments, and I will show you like how we handle error after that Thursday. So common error handling solution. The base thing you can do is using window on error. That's the most basic thing. So this, if you define a function on a window on error, this function is gonna get fired as soon as an error happen in your JavaScript, and it receives these parameters: the error message, which is a string telling you what the error is about, the source code, line number, column number, and the error object. This is the most important parameter, but obviously it's the one that not all the browsers are implementing. And so, and the most curious thing is that IE11 was like sending you the error, Edge not. They decided to. No, it's too much useful, and Safari as well. So you have to know this, because if you rely on the error object, it's not gonna work. The error object it has these properties. These are the standard properties. We will see that there are more and more useful, but basically they are all redundant with the other parameters, with the parameters of the on error. So you have message, line number, column number, but there are more and more and more useful. We'll see. One interesting thing that I didn't know about is that if you load your JavaScript from a different origin, you're not going to see the actual error for security reason. You're going to see script error as the error message, and that's it. So obviously there is a workaround for that. You have to add the cross-origin attribute to your script, and then enable a course on the server. If you have to start with something, this is the best error handler for you. I suggest you to start with this. So basically, every time an error happens in your application, your browser gets redirected to Stack Overflow, and it works. It works. You have in front. You don't even realize that there's been an error. You see the Stack Overflow with the solution. You copy paste. You go back, and that's it. Okay, stack trace or it didn't happen because we have seen. Okay, you have the error message, column number, but that's not useful. I mean, it's useful, but the most important thing is the stack trace. What is a stack trace? A stack trace is something like this, where you have the error message, obviously, and then you have the call stack that generates the error. So, and also you have the file name. As you can see, here is bundle, bundle, bundle. We see that we can do better. And you have all the calls that generated the error. This is something that we want to have. And this is something that the error object has a property called stack, which is what we actually need, but is not defined in the standard, so it's not a standard property, but all the browsers implement it, but in a different way. So, for example, if you log the stack trace in Chrome, you're gonna get error at anonymous, and line number and column number. If you do the same in Firefox, you're gonna get this. At least the column and the number and the line number are the same. Safari is super cool, something like this. Why? Obviously, there are some libraries that can normalize the stack trace. This is stacktrace.js, is my favorite one. And what they do, basically, they try to give you the same stack trace across all the browsers, so you can like be confident that you're gonna get a stack trace, like, which makes sense. The second one is TraceKit, which is used by Sentry, which is an error tracker, the error tracker that we use. But yeah, both they basically try to do the same thing. They try to normalize the stack trace, the error object, and that kind of stuff. Okay, the second common solution is using try-catch. Obviously, maybe some things you can think, okay, this is obvious, but it's not that. At least for me, it's not that obvious. And also, I found out that there is not that many documentation or blog posts. It's not a cool topic, so it's better to know this properly. Okay, so basically, the try-catch is super simple. I guess you all know how it works. You basically mark a function to try, and when it fails, you're gonna get the error object in the catch block. So you put your code in the try. When the code fails, you get an error object, and obviously the error object contains the error the stack trace, which is cool. One thing is that if you catch your errors locally with a try-catch, they're not gonna bubble up to window on error. So for example, if you put your code inside this block here, you're not gonna see the Stack Overflow if it fails. And one common thing that you should do if you do try-catch, you do something with your error after the catch, and then you rethrow the error. So you can let the other libraries or whatever you want to, like add, for example, Sentry or other tracking libraries to do their job. Perfect. So we can wrap our function into a try-catch block, and it's done. No, because the try-catch block has a huge problems with performances. So if you use, because V8 cannot optimize functions inside the try-catch block. So there is this solution, which is, for example, Redux, React Redux is using this try-catch function. So basically, this can be optimized because you create a generic try-catch function that takes a function and it wraps it, and it adds the context to it. So this can be optimized. Obviously, it's lower than not having the try-catch, but at least your function fn can be optimized a bit. Otherwise there is this library. It's not that popular, so I'm not saying to use it, but it's super cool because I love when people try to solve problems like in different ways, in not following like the easiest path, but in like trying something new. This try-catch function takes two arguments. The first is the try function. The second is the function that gets called if an error happens. And what it does, instead of wrapping the function inside the try-catch, it sets up a window on error handler only for this function. And if it throws, it uses the window on error to fire the callback, and then it clean up the window on error. So it's experimental, but it's pretty cool. Okay, now it's the most interesting part, because you may, I don't know, already encounter something like that. Maybe you are not doing it, but you know that you can do window on error and try-catch. But let's see if there's something more that we can do to get useful information. So, custom error handling. First of all, why? We wanted to do custom error handling because we wanted to collect more information. Because if you use, for example, if you use Sentry, as Emanuele said this morning, you can easily, like, you put one JavaScript in your code base, and Sentry is gonna log your errors, but you don't have very useful information because you have the error message, you have the stack trace, and if you don't have source map, we'll see later, you're gonna see bundle.js line 2000. I mean, it's not so useful. Obviously, you can fix the error if you are lucky, but you don't have all the information you would need to fix the errors. And obviously, to make debugging easier. So, okay, there is an error, it's fine. We know that, we accepted that our code is gonna fail, but we want the debugging experience to be not that painful. And that's why we created a specialized solution. So for each blocks of our application, we want to do some special error handling to get the most out of it. So what I've done, I created this repo. Depending on how many beers I'm gonna drink this evening, I'm gonna publish it. Otherwise, tomorrow morning gonna be live. And I created this application, which it doesn't have a UI because I wanted to keep it very, very simple, just to concentrate on the problem. So basically, there are 2 strings on top, which are basically a couple of components. We'll see them later. Then there are some buttons that can throw errors in different parts of the application. You may recognize components, action, reducer, sagas, and selector. So all the different parts of your application, we have created specialized solutions, and also there are a couple of buttons here that can generate a 404, a 500. Those are the operational errors. So we don't consider them errors, but I put them here just to let you know that we can do something with those errors, but they are not actually errors, because you can expect that to happen. You have to deal with them. So basically, we created specialized solution for all of these blocks of the application. That should be an emoji, but yeah, Google Drive is not working. So basically, we do 2 things. For operation, obviously, we are not doing nothing really useful for this demo. We're going to log the information that we are gathering. Obviously, we are not displaying, I don't know, messages to the users, anything, models. We are just logging in the console, but we are logging in 2 ways. One is info, and we use info for operational errors. So we will see that we will receive the error message and also extra information. And the extra informations are the information that we care most about. And then we have actual errors. We log scalar and then error extra. And then, as you can see here, we use stack trace, which is a stacktrace.js library. We pass the error to it, and then we log out the normalized stack trace. It's basically an array of frames, and we transform it to a string, and we log into the console. So that's what we do. Webpack, here is where we talk about Webpack. Webpack can create for you a source map. So basically, a source map is a way to, because you have the big bundle, where if you look at the stack trace of the bundle, you're going to see bundle line 2000. But obviously, you want to know the actual source file and source line and column. So Webpack can create a source map, which is basically a map between the bundle and your source code. If you put this DevTool parameter to eval, you're gonna get the actual source file and number, even without stack trace. But obviously, eval is not good for production. So in production, you just generate a source map, and what stack trace does, it gets the error object, it reads the stack trace property of the error, and it basically merges it with your source map. So giving you the actual file name and line. And we set up also a global handler in the example, but obviously we will never see this working because we are catching the errors locally, and we are not rethrowing the errors like on purpose. The important thing here is that when you set up an on error handler, you should return. It's up to you, but if you don't want your users to see the error in their Chrome console, you should do return true. So you do something with your error, and you tell the browser, don't do anything with it. I done, and so I don't know. It's up to you. You have to decide what to do in this case. I prefer to do that. And so you can say, okay, but if I use only this, it's done. I'm gonna catch all the errors. No. Because if you do something like this, so you import your modules and then you set up the window on error, but you have a throwing module. Obviously, you don't want to have a throwing module, but because you tested it, everything. But if a module, for example, relies on some variables in production, and in production these variables are not present for some reason, boom, it fails. And if it fails before the on error, so you're not going to catch it. And that's again is where Webpack can help us, because Webpack, you can say, okay, this is my index file. Let's start from here and build the bundle, importing all the dependencies. But you can also have multiple entry points. So in that case, we can set up the error handler as the first entry point. So the first thing that Webpack does, it runs the on error handler. So we set up the window on error, and the second is the bundle. And if you do this, you're going to catch all the actual errors. Perfect. So let's start. Let's see how the demo application is going to work. So the operational error handlings. The flow is something like this usually. So you fire an API get function action. There is a Redux Saga watcher that is watching for all the API get actions. When it receives one, it fires an HTTP call. When the HTTP call comes back, it fires, in this case, because it's failing, it fires an API get failure action. The API get failure action, it can have a payload. You can attach the error to it, and you can set up another watcher. It looks very complicated, but it's not. You can set up another watcher listening to all the action with an error object, and you can do something. In this case, we're going to log, but we will see how easy it is to set up a notification system for your user. So this is the code. It's easier than the flowchart. So basically, you filter all the action with an error object, and you take every action that matches that filter, and you run the error handler. And you just call the logger. That's it. The cool thing with the Redux Saga is that you can do something without polluting your code base with login functions. Otherwise, you would have to put the logger.info everywhere in your application, while you can do something like this and get this Saga to be fired when an error happens. And you can very easily change the last line. Instead of calling the logger, you can put another action on the Redux flow, and for example, a notification action. So if you have then a notification system that is listening to notification actions, you can display the errors to the user. But let's see how it works. So basically, we have these two buttons. One is generating a 404, the other one is generating a 500. We are using HTTP bin, which is a super cool tool. It's basically, let me show you. 404. So basically the URL is going to be http.org/status/404. So you can tell them, like, returning to me a 404, which is pretty cool for testing. So what happens here is that we have an API get action. We have a failure, 404 not found. We have an API get failure action that has an error attached to it. So it gets catched by the watcher, and we log info, we log not found, which is actually the error, and also we log the type of the action. And this is the most important part that it can be interesting for you, because if you know the name of the action that failed, you can, if it's I don't know, if it's not important, you can do anything. Just tell the user, hey, something bad happened. You don't care. Otherwise, you can create a button and say retry this action, or I don't know, refresh the page. You can do something according to the action that failed, and that's why we want to do specialized solution, because in this case we have an information that we couldn't have with using Sentry, and that's now you should understand why we've done all of this work, because we wanted to have all the possible information that we could have when an error would happen. And the same thing is going to happen. Oh, sorry, let me just clear it. 500, like exactly same thing, except that you have a different error message. Obviously, you don't want to show internal server error to your customers. You want to do something about that. But you have these two information that are pretty useful. And this is done all about the operational errors. Now comes the part that it should be very interesting for you as well. For me, it has been super interesting. Components. So what? Let's see this thing. Let's see first a question for you. Suppose you have a nice component which prints nice, and then you have an evil component which prints evil, and then it tries to access a property that doesn't exist. If I run this, what's going to happen? No, but the question is more, are you going to see something? Are you going to see only the first nice, the two nice components, what's going to happen? Because I was very surprised, because I would expect, for example, you could expect two things mainly. You could expect that you see the first nice component be rendered and then the rendering stops. Or you can expect both nice components to be rendered and not the evil one. What actually happens? Nothing. Because a single broken component in your tree, no matter like how deep in the tree, if there is one broken component in the tree, nothing gonna be shown. And that's actually very bad. And also, you can think, hey, I can wrap this into a try-catch. Nope, because errors don't bubble up in the tree. Obviously they bubble up to window on error, but if you try catch a parent, you're not gonna get the errors in the children. So it's pretty hard to handle errors with React. And there is an issue but it's open from November 2014 where people are asking, please give us a way to handle the errors. I don't know, a new lifecycle method, whatever, we have to deal with errors. The suggested workaround is monkey patching. We all know that it's actually very wrong. Please go there, add +1. Let's see if something is going to happen. I'm not sure. I'm not sure. They say we don't want to do that because the try-catch is low. It's going to impact the performance, blah, blah, blah. It's up to you to not make your components fail, stuff like that. So the suggested workaround is monkey patching, which is very bad. It's an anti-pattern, but it's the only way to deal with it. We'll see what monkey patch is if you don't know what this is about. There is this library which applies the monkey patching solution. So basically, you import this wrap function from React components error, and you actually pass the component to this wrap function. This can look like an higher order component, but it's not. It's not returning any component. It's just basically monkey patching all the methods. That means that instead of firing component did mount, it's going to fire a custom function that wraps the original component did mount into a try catch. And it's going to do this for all the lifecycle methods and the render. It's very, very bad. It's up to you to decide if you want to show an endless spinner or you want to monkey. You have to find the right balance for you. The cool thing is that you can also, you have a configuration object where you can configure the error render. Because obviously you want to, if you wrap the component with this library, in the case of the evil and nice components, the tree is going to render. You're going to see nice, nice, and you're going to see anything for the evil. But you also want to do more. You want to know that the component fails. So you can set up an error handler that it receives an error report, and this is super cool. So basically, this library wraps all the lifecycle methods into a try-catch block. It has a configurable error handler, but the most important thing is that it passes the component name, the method name, the properties, and the error object to the handler. These are very cool information because when you have the method name and the props and the name of the component, obviously, you can write a test out of it. You receive the error, and okay, you write exactly a test with those properties, and it should fail, obviously. The second one I'm very, very proud of is a library that I created, is React Poop. And it's basically, because I wanted to like do something to improve to add more libraries to NPM. We need more small libraries. This is actually an higher order component. So it returns a component like enhanced. So it wraps only the render method, because in my case, I just wanted to not like stop the tree to render. And it works with the other library doesn't work with stateless functional component because obviously it needs the lifecycle methods. While mine, it works. Obviously, it's no sense because what it does, it renders a poop emoji instead of the component if the component fails. But I learned a lot creating it. Obviously, no, I'm not saying you should not use it. Let's use it. So we'll see here. This is the most interesting part. It's started. So basically, you have the component wrapped with the React components error is basically rendering the string React components error. The component wrapped with React poop is basically rendering the React poop string. So if I press this button, basically I'm gonna send an action that is gonna change a reducer to like changing a flag like should component throw, and it's gonna make the components to throw. And you're gonna see a poop emoji replacing the React poop string, and you're gonna see all the parameters that we receive, the error report from the React components error library in the console. So two things are gonna happen. So the first thing is the poop emoji. So as you can see, it renders something. At least it doesn't stop the tree to render. And also, yeah, if you can see here, if you hover the poop, you can see the error message. So that's useful. And here we see, okay, we fire the action like throw error in components, which is an action that I created just to make the components fail. Then we log the error message, which is actual component. We're going to have errors like component error, action error, reducer error. And here we're going to see the extra parameters. They're pretty useful. You have the component that failed, the error object, the method that failed, and also the props. The props, I guess, is the most important thing because, as I said, you can create a test out of it, and that's it. And also, this huge string of things is basically the output of stacktrace.js. So as you can see here, we can see the actual source file because let me show you this thing. So if you hover the error object, you're going to see like bundle.js, 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 but stacktrace for us using the source map is going to tell us exactly the line and the column that failed. So this is pretty cool, and you have a lot of information here. Some information that you cannot have if you just set up Sentry, for example. I want to stress that that's the reason why we have done this custom solution. Okay, thank you. There is more. Bear with me. It was for React poop, right? So another thing that can fail, you may say, no, my actions are not gonna fail. No, you have to understand and to realize and to accept that your actions are gonna actually fail. In this case, what I've done, we have seen this morning that there is this bind action creators function from Redux that you can use to bind your actions to the dispatcher of Redux. What I have done, I've created a safe bind action creators function that obviously it wraps the original one and it lets you set an error handler. So in this case, if an action fails, the most important information for us is the name of the action, which is something that you don't have if you don't do a custom solution. So basically, we wrap the bound actions into a try-catch block. It catches all the synchronous errors because obviously Redux is synchronous. So from to like the dispatch flow, you can catch all the errors. And it passes the error object, so you can use stacktrace, whatever you want, and also the action name, which is pretty useful. Let's see what happens. So we throw the error in the action, boom. So we have action error, and we have the extra parameter that gives us the action name. The action name is in action because throw error in actions. So in this case, we just have the action name, but obviously we can do something with it. Also, we can monitor how many times the same action is failing, and so you can spot that there is something wrong with some actions. Okay, let's move into reducers. So we are using a third-party library. This is the most interesting part, and it has been very, very useful for us. It's Redux Catch, so basically it's a middleware for Redux that's basically is going to catch all the errors. And you apply the middleware, and you define your error handler. But the most important thing here is that the error handler is going to receive the getState function from Redux. So basically, you have everything you need to spot the error. So, and for us, like the day after we implemented it, we logged on Sentry the error and also the state. And just looking at the state, we realized, okay, the problem is that, and we fixed it. It's super, super, super cool. It wraps all the reducers call into a try-catch block. It has a configurable error handler, and it receives getState. Let's see what happens. So throw in reducer. So we fire the usual action throw error in reducer. We log the error. And this is the state of our, obviously, the state of your application is going to be bigger. In this case, we have the throw error reducer that has, if you can see, you have the component should throw a flag to true because we set it to true before. This is the only state of this application, but in your case, you can have everything. Obviously, you have to take care if you are storing, I don't know, private information in your state. You have to make your customers aware of that you are logging all their, I don't know, credit card data or password, whatever. I mean, I'm not saying to do that, but that's the thing. Okay. And the cool thing here is if you are using Redux DevTools extension, it works for Chrome, Firefox, and Electron, you have a functionality which is very useful, is you can import and export the state. So basically there is an error in your application in production, you log the error and the state, you take the state, you import the state locally using the extension, you reproduce the error, and it's done, it's fixed. It's very, very useful. Sagas. In this case, there is not much to do, but there is one thing to, because I learned a lot doing this, because I had basically to read the source code of everything, because everyone is doing their own strange things. In this case, Redux Saga, if you don't catch the error locally, they're going to catch it for you, and they're going to throw an error where they say you have a non-cog error. So basically, they catch it. They don't let the window on error handler to be called, and they're gonna console log error. So you're gonna see the red bloody string in the console. So this is bad. So there is nothing like special you can do. You just have to try catch your Saga. You can obviously create an utility out of it, but nothing more. The important thing is that you have to know that some libraries can maybe swallow your errors, so you don't even know that they are throwing. This is very, very bad. Last thing is selectors. Selectors is not part of Redux, but as we said before, the reducers change the state, and then the state goes back to the component. But obviously, you don't want your components to receive the entire state of the application. So what you usually do, you create a selector, which is basically a filter. So you filter out the information that you don't want the component to receive. And you usually do that inside the map state to prof function. Now you can spot a pattern here. I created a save map state to prof function that accepts an error handler. And again, it receives the error object, but also the state of the application, which in this case is very, very useful, and the properties, the own properties of the component. It wraps the selectors obviously into a try catch, and it sends you these useful informations. So throw in selector, last one, and you receive the state, which we can see is the same as we had before. So you receive the state again, and the properties in this case is empty, but it's useful. So in this case, again, you have the state, you have the props, you can reproduce. You may be able to reproduce the error quickly, and also you have the stack trace. An interesting thing here, very interesting, is that in the beginning I tried to try catch the errors in the selector, and I couldn't do it. I was wrapping everything and I couldn't catch the errors. I found out that they are doing a weird thing. Let me say just weird, because it's Dan Abramov doing that, so it's a good thing, but it's weird. They basically try catch the errors for you. If the error happens in a lifecycle method like a component did update, for example, they catch the error, so they don't want the lifecycle methods apart from render to fail, and they save the error in this property. Then in the next side, then they set the state, so asynchronously. It depends, but in this case, it was happening asynchronously. In the next cycle. In the render, they check, is there any error? Let me throw the error in the render so you cannot catch it at all. So I have to do like some tricks to do. And this is because if a component fails before render, it goes into an inconsistent state, and so that they want to at least fire the render one. So, but you get to learn a lot of things if you try to catch errors, because there is no standard ways of doing that. So, and this is it. Almost done, almost done. Our spritz is almost there. we have two bonus things. One is serious, and the other one is more stupid than the React poop. And you will tell me which is one is it. No, this one is the serious one. Is the debugging flag. It may sound stupid, but obviously you don't want to try catch all the function in production on your application. But what you should do, you should create a secret debugging flag. Where that basically enables all of these tasks like Redux, logger, and all the try catches, whatever. It's up to you to decide how to do that. But for example, in our case, as I said before, we don't have staging, so we sometimes we to reproduce. See if the error is happening only in production, and sometimes you cannot have like the same data locally. So we want to debug in production because that's how startups work. And so this flag is very helpful. The second thing is Redux, basically error redux, because I was working with error and I got to like love errors a lot. So I tried to recreate Redux but using errors. So basically, it has some feature it's the same as Redux. So instead of actions, you fire errors. Instead of to update the component, instead of like using a subscription, you use the window on error, and you use the reducer. Obviously, one is useful, the other one is not. I mean, it has been useful for me to learn a lot of things about Redux and the error handling, but obviously not use it. But there is a reason why I'm showing you this. So basically, instead of creating actions, you extend error. And then if you want, for example, when a user clicks the increment button, you throw an error. The error obviously goes into the window on error handler, and you can check using the constructor of the error if the error is the action that you wanted to know. Obviously, you can say, but why are you telling me this stupid thing? Because what I found out is that if you try to solve the problem not following the most common way, like the way that you would expect, you want to try catch errors, you add try catch everywhere. No, you got to know how the error works, and the best way for me has been to create this IRDA. And also, obviously, Dan Abramov approves it, so you should approve it as well. Okay. Quick recap, and we are done. Are you telling me to? One friend of mine asked me to add this slide because he said, you are crazy, you cannot tell people to add the try catch everywhere. So I'm not telling you this. You have to find the right balance for your application. So the important stuff is this. Your code will fail. That's it. You have to accept it. You have to find the right balance between performance and error handling. No matter, I'm not talking about testing here. Obviously, your code has to be tested, has to be cross-browser, whatever, Phantom.js, but it's going to fail anyway. And you have to think about the users first, because you can say if you put try catch everywhere, performance are going to be worse, and my users are going to say that my website is slow. But also, like if you have an endless spinner, for example, your users are not going to be very happy. So it's up to you. Decide. You have to find the right balance, and never stop experimenting, as like React poop and all the stuff, and sharing, because that's the most important thing. And that's it.